Let's take a look at this time at number 7. So number 7, I want us to focus in on this being the function we're going to graph, and then we're going to translate everything up 2. So this is a vertical shift up by 2. So think of this as the function that we are working to graph again, and then everything is going to be shifted up 2. Now we don't see a variable on top, so that's the same as x equals 0. Remember, anything raised to 0 power is 1, so 8 times 1 still is the same as 8. But it does allow us to look at the degrees. The degree in the numerator is 0. The degree in the denominator is 2. Whenever the degree on the numerator is less than the degree in the denominator, we will always have a horizontal asymptote of y equals 0. But remember, we have a vertical shift. We're taking the entire graph and we're shifting it up 2. So y equals 2 will be the horizontal asymptote. Now, the vertical asymptote is determined by taking the denominator and setting it equal to 0. And normally we'd say a plus or minus, but we know there's no such thing as plus or minus 0. There's simply 0. As a reminder, our graphs will never touch, cross, intersect a vertical asymptote, but they can cross or intersect or touch a horizontal asymptote an unlimited number of times. When we look at our graph and we're looking at the horizontal asymptote, we are focusing on the end behavior in terms of the input values. What's happening to the far left and what's happening to the far right in terms of input values. And when we look at our vertical asymptote and we compare it to the function, we'll say, as we approach 0 from the right, what's happening to the output values? Are they going up to positive infinity or down to negative infinity? And likewise, as we approach 0, the vertical asymptote from the left, what's happening to the output values as they get large? Is it going up or is it going down? So let's now go ahead and graph this. So I am going to go ahead and I'm going to determine at this time what will be our number. So I'm going to go one number to the right. So one number to the right of this would be 1, and I'm just going to go ahead and plug in 1. 1 squared is 1. 8 divided by 1 is 8. 8 plus 2 is 10. Simple enough. So I went over 1 and up 10. Well, here's 5. 10 is about right up there. And let's just try one more to get an idea of what this looks like. Now, what I know is I know that 1 over x squared, I'm familiar with that graph. And 1 over x squared, I was taught a long time ago by a teacher. It reminded them of looking at a volcano, right? It reminded them of looking at a volcano. So I know it's going to have some general resemblance of that. So if we come back up here, the number on top is going to determine how fast it rises up. Then we can see a shift up of the horizontal asymptote, like the bottom's been pushed up. If I plug in 2, 2 squared is 4. 8 divided by 4 is 2, and 2 plus 2 is 4. So I go over 2 and I go up 4. So I have this general idea of what this looks like. It comes in here. And it's going to get closer and closer to that asymptote. Now let's see what happens on the other side. So on the other side, let's go with negative 1. Negative 1 squared is also 1. 8 divided by 1 is 8. 8 plus 2 is also 10. So I can see that what we have here is we actually have, when we think of like a parabola, for instance, that a parabola, we are able to cut a parabola in half going through the vertex, and the right side will mimic the left side. And the same thing is happening right now. They're going to be symmetrical to the line x equals 0, or the y-intercept. Okay, let's go to negative 2, and we'll see the same thing. Negative 2 squared is 4. 8 divided by 4 is 2. 2 plus 2 is 4. Excuse me. And there we go. So let's go back to what I talked about maybe 2 minutes ago. When I think of this asymptote, the asymptote is going to help me describe my end behavior. So as I go off to the far right values for input values, x's, as I go to the far right for x's, the outputs are getting closer and closer to positive 2. And as I go to the far left to very large x values, or they're really small x values, but like large negatives is what I meant to say, we can see that our outputs is also getting closer and closer to approaching a y value of 2. And for our vertical asymptote, we could say as this function approaches x equals 0 from the right, our output values are going to positive infinity. And as our function approaches y equals 0, the vertical asymptote, from the left, the function also has output values that are approaching positive infinity.